In this lesson, we're going to learn how we can use a HTC VIVE controller to control our particles. Right now, you can see that I have attached my particles to the position and rotation of this VIVE controller. And on top of that, I have some other attributes of my particles, some of their parameters to some of these inputs as well. So I have assigned wind speed to this trigger here. So when I push my trigger, I will see some wind effects showing up and they're affecting my particles. As soon as I release my trigger, that wind effect is going to go back to 0. So we're going to see how we can do all of these stuff in the blueprint. So let's get started. Okay, before I get into these blueprints, I'm going to do some cleanup in my content browser because we kept adding more stuff in here, and I want to make sure that you won't get lost in the content browser because we're going to deal with some actors here as well. So let's expand this content browser. And I'm going to put my Niagara systems in one folder, my levels in one folder, any extra stuff that I'm having here. I'm going to put them in a backup folder and I'm going to hide them and I'm going to remove them from my layout. So we're going to start fresh and you can actually follow me. For now, I'm going to put all the materials and the textures in one folder called materials. So I'm going to grab these. I'm going to put all of my Niagara elements in one folder as well. Putting all the meshes in one folder. Okay, and all the blueprints in one folder. And I'm going to show you how we can create those blueprints. So for now, I'm doing some cleanup here so we can start fresh. I kept one of my Niagara systems here because this is the one that we are going to use for this lesson. So let's just keep that here for now. And then later I'm going to move that to the Niagara folder as well. Let's go back to our level and I'm going to delete these particles that I've already added here. And we are having a very fresh empty scene right now. So the particle system that I'm going to use for this lesson is going to be a very simple one. This is the sparks that I have created, nothing fancy. This is actually almost close to what we used in the previous lesson. And I also removed any user parameters here as well, so we start fresh. So the first thing that I want to do is, as I mentioned, I'm going to track my VIVE controller and I'm going to attach its position and rotation to the emitter here. So of course I need to have one user parameter here to be able to use or expose in my level to act as the position or the origin of my emitter. So let's start by adding the first parameter here. It's going to be a vector because it's the position of the emitter. And I'm going to name this my emitter origin. And I'm going to connect that to my sphere location here. This time I'm going to use the sphere origin rather than the offset because I can keep the offset to be available for me to do some more fun stuff with that as well if I want to. So I'm going to connect my user parameter to the sphere origin this time. My emitter origin. Nothing will change because this is by default 000. So let's save this. Go back to our scene. And I'm going to drag this Niagara system for now and drop it in my scene so we can see and just make sure that it's working. And since I've connected the emitter origin to a new parameter that is 000, regardless of where I place the Niagara system, the emitter is going to be always at 000. That's here. So let's just make sure that this attribute is working. Yeah. All right. So we can see our particle system. And the next step is to connect that to our VIVE tracker. This time I'm going to do that in a new actor node rather than doing all the codings in the level blueprint like we did in the previous lesson. If you remember, I did all the connections and the codings in the level blueprint. But this time I'm going to just ignore all of these. I'm going to leave them here. They're not going to do anything. Even I can delete them. And we are going to create an actor and we're going to do all the coding for that actor because we want to be able to treat this new system as an actor so we can drop it in any level if we want to. So that's the reason why I'm not doing the coding in the level blueprint. So let's delete this Niagara system because as I said, we are going to convert that to an actor and then we're going to use that actor in the scene in the layout. Just to prove that I'm not relying on the level blueprint at all, I'm going to delete anything that I have here. These are from the previous lesson, so nothing in the level blueprint. making sure that things are working. Very nice. And let's start building our own actor, our own pawn here. So what we are going to do is we are going to create a new actor, a new blueprint. So I'm going to right click here and I'm going to create a new blueprint class. And I'm going to choose its type to be an actor, the simplest one. So I'm going to create an actor here, which is a blueprint. And I'm going to name this blueprint Sparks. In this blueprint, we are going to load this Niagara system and do all the coding inside of that. And then when we are done, we will drop this blueprint in the scene. That's the plan here. So right now, this blueprint is empty. Nothing exists in it. So no code, no functions, nothing in the viewport as well. It means that if I drop it in my scene, nothing will show up too. So if I go to the game mode, nothing is here because that blueprint, that actor is empty. So let's see how we can load all of these in this actor. I'm going to double click on that. And in the blueprint here, we are having a viewport that we can see all our geometries and systems, anything that we add in the actor. And in the event graph, we are going to add our codes there. The first thing that I need to do is I need to bring in the Niagara system in this viewport of my actor, of my blueprint, so I can play with it. So in order to add components into our actors, we need to go to the Add Component button here. And I know I'm looking for a Niagara system, so I'm going to add a component of type of Niagara particle system. And in here, I'm going to load my own Niagara system Sparks. This is how you will load components into your actors. So let's save this and make sure that it's loading that. It's right here. I'm going to bring it up. And if you remember, the origin of that Niagara system is set to 000. That's why we cannot see that above the floor. But definitely you can see that it's there, right? So this is my blueprint called Sparks. Inside of that blueprint, we have a Niagara system loaded, which is right here. So let's start doing the coding in the event graph. Anytime that you're going to use keyboard inputs or any type of inputs in your actor blueprints, you need to make sure that you enable the inputs for that actor. Previously, in the previous lesson, we did all the coding in the level blueprint. In the level blueprint, it's always accepting keyboard inputs. In custom blueprints, in actors, we need to enable that. That's the first thing that we are going to do. However, for now, since I'm not going to use any keyboard inputs, I'm going to skip this part. Soon we're going to get back to it because we might need to do some keyboard shortcuts here as well. So in order to be able to read the position and rotation of our VIVE controller, we need to use a command here which is called get tracked device position and orientation. This will help us to track any device that is defined by this device ID, and it's going to give us the position and the orientation of that device. So in this case, I have 2 base stations, 1 headset, and 2 VIVE controllers. So technically my device ID is somewhere between 0 to 5, and we're going to figure that out manually. So we're going to do some experimentation and see which one of the controllers is which ID. There are plenty of tutorials and methods that help you to automatically update this device ID. But as I mentioned, this is not the goal of this tutorial. So we're going to just see which one of the IDs belong to that specific controller that we are going to use. Let's assume that it's 2, and we are going to use this position and orientation to connect them to our Niagara system attributes, right? So we know that this Niagara system has a parameter called my emitter origin, I believe I named it. So we're going to use the same method that we did in the last lesson to set that variable to a specific number. And we know the command for that was set Niagara variable. And since again, this is context sensitive, you have to make sure that if you're not able to see that specific function, just turn this off and you should be able to see that function. We are looking for a set Niagara variable of type of vector, which is here. And it's looking for a target. It will automatically create a node for that target for us. If it didn't, we can just drag this Niagara component and drop it here, and then we can connect it to our target. So it's the same thing. Next is to specify which variable we want to set the values to. So let's go back to our Niagara system and just copy this name of the variable that we've created, and I'm gonna paste it here. It's a good practice to use copy and paste rather than trying to type the names, because there is always a typo in the names. So we want to set the emitter origin to this value which comes from our device. So I can just drag this and connect it to my Niagara system. We just need to make sure that we execute this function. So I'm going to use the event begin play. So it's always tracking my device. Let's save, go back to our layout and hit play. If my device ID is correct, I should be able to see the results. It appears to me that the device ID is something else. So I'm going to my blueprint and I'm going to change this number to something else. Save. So I did a funny mistake. I'm using the event begin play. I'm not using the event tick because event tick is going to run for every frame or every tick, but event begin play is going to just execute once. So I'm going to use the event tick, and my device ID right now is set to 3, but let's see if we have that kind of device in our level. I'm going to hit play. So it appears that one of my controllers is actually having an ID equal to 3. So we have a successful connection now. Everything is connected to the VIVE controller and we are happy. The next step is to be able to connect the rotation of this controller to the rotation of our emitter, because currently, regardless of the orientation of this controller, the particles are always going to spawn in the same direction. Okay, so let's try that. I'm going to go back to my blueprint, and this time I'm going to use the orientation and connect it to my Niagara system. In order to see some direction on my particle system, I'm going to add a velocity here. So I already have a velocity here. Let's just reset all of its attributes back to 0. This velocity will help me to define some direction for my particles as well. Currently, if I set this z direction to 5, you're going to see that these particles are going to go up with some speed. So let's just increase that to 50 or 500. So you can see they are actually going upward, right? So I can connect this to a new attribute that I can name it, for example, direction, and then I can connect it to my VIVE controller's orientation. Since I want to just deal with direction but not the value or the amplitude of this velocity, I'm going to just simply, you can see that I'm dealing with high numbers here. I'm going to multiply by a float value. I can actually do that in the blueprint. Let's just do that in the blueprint. So let's reset it back to 0. I'm going to create a new parameter, type of vector, name this my wind direction, and I'm going to add it or connect it to my velocity here. My wind direction. Everything is 0, so we are good. Let's go back to the blueprint, and I'm going to copy this function, paste it here, and this time I'm going to change the name of variable to the new variable that we have just created. Copy and paste. Let's make sure that it does execute, and then we're going to read the orientation to the value that we're going to use. It will convert the value to the value that is acceptable by this function, and we should be fine. However, I know that the value that we get here is always between -1 and 1 because it's only a direction. And since I'm using that for a velocity, I need to increase that value. I need to multiply that value by some higher values. And I want to multiply all of axes with the same number. So I'm going to use multiply vector by float to make sure that I'm scaling them all up in all axes at the same time. And I'm going to use this multiply result into my Niagara system. I'm going to multiply that by, let's say, 50. Let's save this, go back. There is an error there. All right, let's see what we missed there. There is no target defined for that, so I can either use this Niagara here and connect it to that as well, or I can drop a new instance of it. It's all the same. All right, so position is connected. And let's see if the direction is working as well. It seems that it is. Let's increase that multiply value to something higher so we can see the direction. 250. Play. Very good. So position is connected and rotation is working too. Up, down, left and right. Awesome. So we are done. However, I want to just make it a little bit more interesting by leveraging these triggers and the buttons on the controller too. So let's see how we can use that, because this is the part that will get a little bit more complicated. I'm going to start with a simple example here. So let's say we want to control this value, right? This value that I'm having here. I want to be able to change that in the game mode. So I want to use some of the triggers to be able to increase or decrease that. I'm going to start with a keyboard method of that, and then we're going to use the trigger to be able to control that. All right. If you remember from the previous lesson, we do have access to the keyboard button, so I can type in keyboard. I'm going to use greater than and less than buttons on my keyboard. One of them is on comma, the other one is on period. So this is the first button. And I'm trying to use these two buttons right now. So the period and the comma. Keyboard, comma, it's the name of that. So let's use these two to be able to increase or decrease this value. For that reason, since I cannot directly use these buttons to increase or decrease this value, I'm going to use an attribute here. I'm going to use a variable here to be able to set it or get it in my blueprint. So I'm going to create a new variable called wind speed, and I'm going to change its type to float value. And I'm going to use that in my multiplier by getting it. I'm going to drag it over here, and I'm going to get its value, and I'm going to connect it to my multiplier. That's the first step. Whatever we have in this value, whatever we have in this variable, it's going to be multiplied by the direction, and it's going to affect my Niagara system. Let's compile this so I can define some initial values for this attribute as well. Let's say our own 250 value. Nothing fancy, so things are back to their original mode. Everything is working now. I'm using my tracker, and you can see that we have that same 250 value for the scale of our wind. Now we want to use these inputs to be able to change that. So what I'm going to do is I'm going to set this variable this time using some inputs. And the value that I'm going to set it is depending on whether I'm pressing on the period or comma. So let's just focus on the period for now. Let's say we want to have the period button to increase the wind speed. So I'm going to read the current value of wind speed, whatever it is. And I'm going to use an add function, add float by float. And let's say we want to increase it by a value of 10 each time that we press the period button. So we're adding the current value of wind speed, whatever it is, to a value of 10. And we want to set our wind speed to this new value. We just need to execute this function. So I'm going to use the pressed output of my period key, and I'm going to set the wind speed to the new value. Let's go back, save. And here I'm going to just make sure that things are working, and then let's try the period button just to see if it's increasing the values. It's very hard to see if it's working or not. It's always recommended to have some checkpoints in your codes. So in this case, I'm going to use a print command to print the result of this and see if it's increasing it or not. Let's connect the execute out to the print string and print the current value of our wind speed and see if it's functioning. So save. Go back. It is connected to the position, but let's press the period button. We are not getting any output there. We are not getting any print statements in our game mode. So there is something wrong in our blueprint. The problem here is that all of these keyboard inputs, they are not active in every single blueprint that we drop into our level. So in order for our level to be able to respect all of these keyboard inputs in each one of these actors, we need to enable the inputs for each one of these actors. This is only because we want to make sure that if we are having multiple actors in the scene with multiple blueprints with them, there is no clashing between all the keyboard inputs that come with each one of these actors. So we want to intentionally activate or deactivate each one of these inputs for each one of these actors. Anytime that you're having keyboard inputs in your actor blueprints, you need to make sure that you enable those as well. So you need to use an enable function, enable input, and this enable input is going to enable the inputs for any given player controller. Here we need to specify which player controller we want to activate the inputs for. Luckily, it's always the same, so I'm going to use get player controller, and in this case, I don't need to change anything here, and I just need to execute this enable input only once, so I'm going to connect my event begin play to my enable inputs. So this is only here, and it's going to be executed only once whenever we go to the game mode, and it's going to enable the inputs for that actor. So let's hit save, go back to our level, hit play, and I'm going to bring in my controller, and let's see if our keyboard input is working. Still, it's not working. one thing to keep in mind is that whenever you are going to use any kind of inputs in your blueprints, when you go to the game mode, you have to click in your game to make sure that your game mode is active. So now it will accept the inputs for my keyboard. And you can see I'm not only getting some numbers on the left side of my panel, but also it's definitely increasing the wind scale as well. So I keep adding that, and you can see that it's adding to the wind scale here. Let's do the same thing for the comma key button. I'm going to go here, and I'm going to borrow some of these, copy and paste. I'm going to set my wind speed, and rather than adding values to that, I'm going to subtract some values, and everything else is the same. So let's save this, go back, and then I'm going to add more speed, and I'm going to reduce some speed. Next is to see if we can connect that to this trigger button here. So we want to see if we can connect it to this one. Okay. So let's go back to our blueprint here. I'm going to keep these here as for now. And we're going to see what are the functions to read the key buttons, the keystrokes of our VIVE controller. So similar to the keyboard inputs, we're going to see if we can find those inputs here for our VIVE controller. So if I go to my inputs, and here you can see that we have keyboard inputs. So these are all the buttons that are on our keyboard. But let's see if we can see HTC VIVE controller here. Unfortunately, I can't see that. We have gamepad events. These are, for example, if you are using a Xbox controller. We have Oculus inputs here as well. We have PS4 events. So all of these are listed here except the one that I'm looking for, the HTC VIVE controllers. If I was using Xbox One controller, then I could just use these inputs here. So I could just drag these and I could use these ones to change the values of my attributes. If I was using an Oculus input, then I could just use the ones that I'm seeing here. But for VIVE controller, for HTC VIVE controller, I'm not seeing that in the list. So I need to figure that out and solve this issue. This leads us to a new topic that helps us to create our own inputs in the blueprint if we are not able to see them in the blueprint. To solve this issue, I'm going to go back to my project and I'm going to go to the project setting. And in the project settings, we also have a whole bunch of inputs that we can define. These are going to be our custom named inputs that we can assign any type of input to them. Any controller, any VIVE controller, any tracker, anything, we can assign them to these custom inputs and then we can call them in the blueprint. So this is what we are going to do now. As you can see, I've already created a bunch of these inputs for one of my VIVE controllers, but I'm going to delete all of these just to show you what we can do from scratch. And we are going to use action mapping rather than access mapping. So I'm going to click on this plus sign button, and whatever name I give this action, I can load that or I can see that in the actor blueprint later. So let's start with a simple one. I'm going to say write VIVE, and let's name this one trigger. Okay. This is the name of the function that I'm creating. And here I can see that HTC VIVE is showing up here. So that's good. HTC VIVE. And it will list all of the buttons that come with an HTC controller. So we have system, we have menu. This is called trigger. This is called touch, up, down, left, and right. And we have the touchpad itself as well. So the button that we are looking for is called trigger. So I'm going to use the trigger for now. And what I'm doing here is I am defining a new function called write VIVE trigger, and I'm assigning this button to that. And you can see that I did a mistake here. I chose the left VIVE controller rather than the right. So I'm going to go back to my HTC VIVE one more time. And I'm going to use the right HTC trigger button. Look at this name. Now it's going to show up in my blueprint when I try to use that as a function. So if I hit tab and if I type in VIVE, you're going to see that I have an action event called write VIVE trigger. This is exactly the name that I gave to this function. So this will treat it as a new function. Whenever I call this, it's going to go back to my project setting. It's going to see what I have mapped that function to. So if I go to the inputs, I'm calling this name, it knows what it's supposed to do. It's supposed to read the VIVE write trigger. So let's go back there, and I'm going to connect that to my increment function there. And you can see we can have multiple inputs for any command there as well. All right, let's go to the game mode. Make sure that you hit your mouse button just to activate your game. And then I'm going to use the trigger to see if it's active. You can see on the left, it's increasing the speed. And of course, on the particles, you will notice that it's in fact increasing those values. So that was a successful connection. Let's use the grip button here for decreasing those values as well. Go back to my project setting and inputs, and I'm going to add a new function, and I'm going to name this right. I'm going to name this right VIVE grip, and I'm going to look for VIVE right grip, and I'm going to hit tab VIVE grip. All right, save. Go back to the game mode, and connection is made. Increase the speed. And pushing the grip button, it's decreasing the speed. So things are working. We are technically done, but I'm going to just make it a little bit more interesting just to show you how far you can go with the blueprints. I thought maybe it would be nice if you could use the buttons to have them act as a hold button. So for example, if I hold the trigger, it will keep adding more values to my wind scale. And then as soon as I release my trigger, it will start dropping down. This is more a blueprint exercise rather than a Niagara exercise, but I feel like it's worth it to go over that as well. Just for now, let's just make this blueprint a little bit more clean. I'm going to remove my keyboard inputs for now. And I want to just focus on VIVE inputs. Let's push this away and let's focus on increasing the values for now. I want to just say if my VIVE trigger is pressed, keep adding to the values. First thing that I need to do is I need to bring this up and get it closer to my overall event tick functions. And I'm going to use a conditional statement here, reading the state of my trigger first. And depending on that state, I want to do either increasing or decreasing the values. So in order to be able to hold this state somewhere so I can call it later on, I'm going to create a new variable and I'm going to call it is right trigger pressed. And it's going to be either yes or no. So I'm going to leave it as a Boolean type. And I'm going to both set it and get it in multiple places. So first let's set its value to either yes or no. So I'm going to use this trigger here, which is my VIVE trigger. And if it's pressed, I want to set this variable to yes. If it's released, I want to set its value to no. The whole thing here is trying to read the state of my VIVE trigger. It's either pressed or it's released. So my variable, which is a Boolean, is either yes or no. And we're going to use that in our functions. In this event tick, where we are doing all of the constant executions, we want to create a branch. And the condition for this branch is going to be the state of my trigger, so which is stored in this variable. So I'm going to get its current state and I'm going to execute whatever comes after this branch. So event tick comes here, checks the condition. If my trigger is pressed, it will keep adding to my current value because I'm using the event tick. It will keep adding a value of 10 to the current value of the wind speed. If it's released, if this value is false, I want this to keep removing those numbers, keep reducing that number. So I'm going to bring this up and put it here. And rather than connecting it to the VIVE grip, I'm going to use the false output here. So let's save this and see if we did a correct setup. Go back to my level, bring in my controller. You can see that since I'm not pushing my button at all, it's reducing a value of 10 from my current value of wind speed. So it's going to the negative direction, which is not what I want, but it's working. If I push my trigger, if I hold my trigger, you're going to notice on the left, the values are now adding up to positive numbers, right? If I release my trigger, the numbers are dropping. If I push it again, it's going to add it more and more, right? So it's functioning. I just need to do some controlling of the behaviors here. I want to just clamp these values to some certain numbers so it doesn't drop below 0 or it doesn't go above a certain value. So let's do some cleanup in the blueprint. So here I'm going to use a clamp float, and whatever value I'm getting here, I'm going to clamp it between these minimum and maximum values, and I'm going to use the result here. So this clamp function is helping me to limit my inputs to some certain numbers. I don't want it to go below 0. I don't want it to go maybe even above 500. And I'm going to do the same thing for the reduction values. So I'm going to paste this and I'm going to drop it in between here. So between 0 to 500. Here we go. Save, go back to the level, hit play. It's dropping to 0. Now if I hold down my trigger, it's adding the values up to 500 and it's going to stop there. As soon as I release my trigger, it's going to drop those values. So it's working completely and we are happy. I want to make the dropping part to go a little bit faster. So in my blueprint here, I'm going to reduce it by a value of 50, for example. So it's going to faster drop to 0. Push, 500, release, drops to 0. Goes up. And again, if you're not happy with how fast it goes up to 500, you can always go back and change your steps here. So you can change this to a value of 20. Very nice. And of course, we are using these print screens just for debugging purposes. When you're done and everything is functioning, you don't need them because you don't want to clutter your scene with those numbers. So I'm going to disconnect these by holding down Alt and clicking on these execution buttons. So I'm disconnecting them from the setup. And then I'm going to go back here and I'm going to try it one more time. Again, you're noticing that it's going faster, it's dropping faster, and I'm not distracted by those extra numbers on my left side of my panel. If you like, you can always go back to your default value for the wind speed. Currently, it's starting from 250, and because of this function, it's dropping to 0 immediately. So I'm going to start with a 0 value for the wind speed, so it doesn't make any distraction there as well. Making sure that it's active, and then my trigger. Awesome. And at the same time, things are working with the position and rotation too. So I'm going to hold the trigger and I'm going to change the direction of my particles at the same time. I'm going to show you one other example that I have created here, which might be a little bit more practical for your virtual production setups. Right now you can see that I'm changing the direction of the wind here by rotating this VIVE controller. So I'm having control over these leaves in my scene. And one of the applications for this one was that probably on your set you might have a fan that is blowing to your character's hair. And then you want to add these leaves effects to your scene as well. So you can connect your controller, your tracker to the fan that you have on set. And whenever the fan is rotating or spinning, it will also affect your virtual world. So I feel like this is a nice example of how you can leverage these connections between your real world and your virtual world. So the key here was to make sure that you're having those input mappings in your project setting. And you should do that for all of those inputs as well. If you're planning to use all of the buttons on your controller, you need to do this for all of them. So if you remember in my first thing that I started the lesson with, I had a huge list of all of these inputs. That's normal. So that's it for this lesson. I hope you learned something and you're going to use these tricks in your projects in future.